Okay, this is a recording for Tuesday, September 17th, and we're going to finish up our notes for 04. I did not go over a little piece, just a little bit above this, but I do want to just kind of go over that, and that is knowing how we get, back and forth from this fractional exponent to a root with a different index as we look at that. And so it is worth it to me to just kind of go through that just briefly and show you what that looks like so that as you're working on things, you kind of know where that comes from. I am going to go to another slide. It's above this slide, but I will go through this. So we know that the square root of b is equal to b to some power. So we're just going to say this is just the square root of b, and we want to rewrite it as b to some power. N is going to be the power that we use, and we know that this is just a plain old square root. And so I'm just going to rewrite it. The square root of b is b to the n, because then if I want to get this b alone, I'm going to square both sides. And when I square both sides, the square root of b squared is just b. And then this is b to the, when you raise a power to a power, you multiply. Just give me a little head nod that you agree that that's what you do when you do that. And instead of writing n2, I'm going to write 2n. So this is b to the 2n. And then also, we don't necessarily write this, but do you agree this b is b to the first power, correct? Yes? So this is b to the first power. So if this is b to the first equals b to the 2n, then that means these exponents are the same. And we'll do problems like this as our year goes on. So that means that 1 is equal to 2n. When we divide by 2, we get 1/2 is equal to n. And then when I go up to here and I rewrite that, that means that the square root of b is equal to b to the 1/2. And so that's that fraction. And we could do that for the 4th root, for the 5th root, for the 12th root. Just kind of think about this. If that index was 12 instead of 2, I would take this to the 12th power, that to the 12th power, and then this would turn out to be 1/12. So that's just kind of a little bit of information about how we get to that fractional exponent. So if you remember yesterday, we did things like this, the cube root of n to the 5th. And we did it by pulling out the perfect cube roots. So this is the cube root of, maybe we would say n to the 3rd times n to the 2nd, and then the cube root of n to the 3rd. Just a little review, times the cube root of n squared. That stays in, and this becomes just n. So it would be n times the cube root of n squared. Now, that's how we did things yesterday. We're going to approach those same kind of problems today a little bit differently. And we're going to approach them using fractional exponents instead of roots, square roots. So one little note I'll say to you is, if you like what we did yesterday and that was a little easier for you, you can gravitate a little more to that. If you like the way we do it today, you can do that a little bit more. In my opinion, the fractional part, because we don't always like fractions, but the fractional part allows us to simplify sometimes, in my mind, just a little bit better. So here are some things, and also I'm just going to point out this little note. It might be hard for you to see, but b to the negative n. B to the negative n, I'm going to write it a little different order. B to the negative n is 1/b to the n. Just give me a head nod. Do you remember that? If you have a negative power, that it's 1 over that. So 2 to the negative 3 is 1/2 to the 3rd. So that's something that we've covered before. The reason we want to say that is we want to be careful and say b to the negative n is not b to the 1/n. It's not that power that we make into 1/n, it's 1 over that whole thing. And it also could be, so that's not right, but b to the negative n is 1 over b to the n. I'm sorry. So b to the 1 over n, which is a different question, is the nth root of b. So there's a lot of different little things there that we have to be aware of. So I'm going to do this as fractional exponents. Just give me a head nod right now. Do you know 32 is a power of 2? Yes or no? It's either yes or no. Do you know it's a power of 2? Okay, and I'll just I'll do a little factor tree because I saw some no's. So 32, anything times whatever is 32. I'll go 8 times 4, and then I'll take this as 2 times 4. This is 2 times 2. This is 2. This is 2, 2, 2, and 2. So 32 is 2 to the 5th. And that factor tree is just allowing me to rewrite 32 as 2 to the 5th. Do you agree with that? Do I have a mistake? Oh, I'm going to write it in just a minute. I just wanted to clarify that 32. So this is 3a. It's the 10th root of 32 over the 6th root of 2. And I forgot that I wanted to review one other quick thing with you. So before I do this problem, I'm going to add a little page. And do you agree that x to the 6th over x to the 4th is x squared? That's my whole review of that. Do you agree with that? Because and the way we can do that is x to the 6 minus 4. Do you remember that? Okay, and so that's x squared. And then we've already said, you know, if I have x6 to the 6 squared, we multiply those, and that's x to the 12th, right? And if I have x to the 4th times x to the 3rd, that's x to the 7th, right? Because I add the 4 and 3. And the reason I just wanted to review that is everything, the 6, 2, 4s, and 3s are all whole numbers, correct? And we're going to have fractions now. So I just want to make sure we remember the rules up front. Does that make sense? We want to remember the rules up front. And then when we add or subtract, the fractions shouldn't be, in my mind, too terrible for us as we go. So here it is. Back to this problem. So this is the 10th root. And so that means I can write this as 32 to the 1/10 over 2 to the 1/6. Everybody with me on that part? Just give me a head nod right now because I need to know if I'm pulling you with me or, you know, not. Okay. So these roots we can write as a fraction. And that's all we're doing right this minute. Now, rules tell us that if that 32 and that 2 are not the same number, then we can't add those powers. Like the one I just did, x to the 6th over x squared, is that what I did? If it had been x to the 6th over y squared, we couldn't do that. Do you agree? So those have to be the same kind of bases. But we just said 32 is 2 to the 5th. So I'm going to take this 32 right here, and I'll just kind of circle it in red. I'm going to take that 32 and I'm going to change it to 2 to the 5th, and I'll put it in parentheses, and now it's still raised to the 1/10, and this is 2 to the 1/6. Oh, I forgot an equal sign. Now, remember a power to a power we multiply, and that 5 is like 5 over 1 times 1 over 10. Do you agree that's going to reduce, correct? To 1/2. Is everybody on board with that being 1/2? 5 over 10 or 1/2? So that means that this is, and I'm just going to kind of go over here, that's 2 to the 1/2 over 2 to the 1/6. So 5/10 turned into 1/2. And now I'm going to use what I did on that other slide. If it was x to the 6 over x squared, I subtract those powers, correct? Yes? And so the bases are the same. So this is going to be 2 to the 1/2, just a second, 2 to the 1/2 minus 1/6. Now, we might not super be excited about that. Say it again. So I have to get a common denominator, and I don't like the way that turned out, so I'm just going to rewrite it. So it's 2 to the 1/2 minus 1/6. And I tried to write it big enough, hopefully, that I can get a common denominator if I multiply that by 3 over 3, right? That's going to be 3/6 minus 1/6. Question? I did this factor. The question is, how did I make that 32 into 2 to the 5th? And here's what I first did. First, I noticed that, that this 32 and that 2 are not the same base or the same number, right? And so I'm looking for the factor tree. The factor tree, and then I put it so that it's the same bases. And now I'm going to get this common denominator. So that's 3/6 minus 1/6. And I think I can do that in my head. So that's 2 to the 3/6 minus 1/6 is 2/6. And so then it's 2 to the 1/3, which is the cube root of 2. Now, I want you to just look at this a minute and notice that we started with 10th roots and 6th roots. Do you agree? And think about the work that we did yesterday and how much harder it would have really been, because we can't take any of those out. But we can manage those roots by changing them into fractional roots. Question? So the question is, suppose, I'll just circle this right now. Suppose this had been flipped upside down, correct? So suppose this had been 2 to the 1/6 over 2 to the 1/2, then when you subtract, you're going to get a negative exponent, correct? And when you have a negative exponent, that means you're going to do the reciprocal. So actually, you would take that whole fraction and you could flip it upside down again, is one thing that you could do. Or you can rationalize that denominator if you turn it back into this. So I'll pretend that a minute. So it would be 2 to the 1/6 minus 1/2, and then that would still be 3/6. So it would be 2 to the negative 2/6, or 2 to the negative 1/3, right? Do you agree? And then at that point, and I'm going to erase everything that's in red right now because it's just a little made up variation of this. So if I had that though, I can do one of two things. I can say the negative power, it's 1 over 2 to the 1/3. Do you agree with that? Because it's the reciprocal of that makes it positive. So, Colin, we're 13 minutes into this recording, so from 13 minutes on is what you're missing. And then we can take that to the 1/3 power, and then we have to rationalize the denominator. So it's a little longer problem. Do you want me to keep going on that, or was that enough information for right now? Okay, so let me just try to get rid of this red stuff and without messing up everything. Okay, because I just want the problem that we did. Okay, now we're going to do a couple more problems, and I'll write them because I know they turn out to be a little small. So problem B is the 4th root of x to the 21, y to the 15. So I just want you to reflect back to yesterday's work, and I would say this problem, if you wanted to do it like yesterday's work, you could. Do you agree with that? Pardon? This is, yes, 3B. This is 3b. We could do it like that, but we want to kind of experience this fraction. And think about the fact that if I have an improper fraction, I can change that kind of into a mixed number, we'll kind of say it that way, and then that whole part, that is the whole number, that's going to be outside of the radical, and then that fractional part that's left over will be inside the radical. So first of all, I'm going to just rewrite these as fractional exponents. So that's x to the 21 over 4 and y to the 15 over 4. And then I'm going to say, and just like we did before, 4 goes into 21 how many times? 5, right? And so 20 of those 21 are kind of perfect. So I'm going to keep it as an improper fraction just a minute, and I'm going to say this is x to the 20 over 4 times x to the 1 over 4. Just look at the x's and make sure that you agree that it is still equal. I just took out, these are going to be, you know, this is going to reduce 20 over 4 to a whole number, and then there's still 1/4 left. So who thinks they can tell me how I'm going to break that y to the 15/4 up? Who can tell me how I'm going to do that? Yeah, so they have to add to 15 over 4, and 12 over 4 will be like the perfect one, and then the 3 over 4 is still going to be under the radical as we go. And then just because we have people gone, I'm going to write this in a different color. I wouldn't necessarily also have to write this, but I'm going to rewrite these two in front and then the two that I didn't underline in the back. And when I write them in the front, I'm just going to write them as whole numbers. So x to the 20 over 4 is x to the 5. And y to the 12 over 4 is y to the 3. And then I'll just leave those as fractions a minute, x to the 1/4 and y to the 3/4. And these are regular just outside of a radical, right? They're just to the 5th power and to the 3rd power. That's just what they are. But do you agree these back two are 4th roots? Give me a head nod. Do you know that those back two are 4th roots? So then I can write it one more time, and this time I'm going to write it, oops, I didn't want to lose it that much. Then I'm going to write it as x to the 5th, y to the 3rd, and then I'm going to change this part back into the 4th root of x to the 1st, so I'm not even going to write a 1, y to the 3rd. X, y to the 3rd. Oops. And then that's it, yeah. So I've pulled out all those perfect factors, 4th power factors. Now, for this one, if you kind of go back up to the original problem, we could do it like we did yesterday, but we want to be good at manipulating a little bit these fractional powers as we go. So our next problem is this one. Now, this is a unique problem for several reasons. Do you agree that the bases of both of those are 16 and they're the same number, correct? So because they're the same number, we can leave them 16, and I think this was your question about the 32, remember a while back? So the one was 32 and 2, and we had to change them. Well, these are 16 and 16. We can leave them that way. But do you agree that 2 times 2 is 4, times 2 is 8, times 2 is 16? I could change both of those 16s to 2 to the 4th. Give me a head nod on that. Do you agree? So no, I'm just telling you that I could if I wanted to. I'm not going to. I'm going to say because those are both 16, I'm just going to leave it that way. But suppose like that first problem, suppose instead one of them was 16 and one of them was 32. Then I'd have to change them to 2 to whatever. But I'm just saying because they're the same number, we can leave them as is. So this is 3c. And this is 16 to the 3/4 over 16 to the 1/4. And I will tell you that when I type tests, it's very difficult to type like fractional exponents just because they get tiny-ish, on printing. But I can do it. And so I just also ask that when you're writing, you might write a little, if you're a tiny writer, you might write things a little bit bigger just so that your powers are legible. Do you know what I'm saying by that? So just yourself. So for this one, it's 16 to the 3/4 minus 1/4. And so we couldn't have a better fraction problem. The bases are the same, the powers have the same denominator, and so I get 16, 3 minus 1 is 2/4, and so I get 16 to the 1/2. And that 16 is also a perfect square, yeah, and we're taking the square root. So this is the plain old square root of 16, and what is the square root of 16? 4. 4. And just a reminder, that square root, we don't write that index as we're looking at that. Okay, so that is the problems that we're doing. And so let me just go over some announcements before we do anything else, just so that I know. We're done with the instruction part of 04. You're to bring your Chromebook Wednesday and Thursday, and it should be charged. So tomorrow you'll be taking the STAR test, and then Thursday there will be an in-class assignment, and if anybody needs to, you'll finish the STAR test. And then Friday, we'll take the quiz on 0304, and that's all kind of listed here as well. And you know that homework 4 is due on Thursday. Now, what I'm going to ask, and I know that it's hot, but I am going to ask that everybody in this room is actually working on this section, and I'm going to give you some homework work time. If you need a book, I'll lend you one, or you can use your Chromebook or your textbook. But I want to be answering your questions, and I want you to be working on this in my presence. So I'm going to stop the recording. I'm telling the people who are not here that's what we're doing. I'm also going to go over STAR results from last year with different people as time goes on.